Okay, here we go. 1.6, dividing whole numbers. And don't you worry, we got fractions coming and decimals coming. We have all that fun stuff. So right now we're on whole numbers, and then we go to decimals and fractions. I forget which order. I think decimals is first. Okay. All right. Division is the process. I never heard it explained like this before. This is in your book. Used to separate quantities. So if you divide by a number, you figure out how much was left over. So you sort of separate quantities. There are many forms to show dividing. So a lot of people don't know one of them means dividing, but I can do 100 divided by 5. I can do long division way by showing 5 that goes into 100. I can show, a lot of people don't realize that division is just dividing. So if you ever want to put a fraction in your calculator, but you don't have a calculator this class, you would do 100 divided by 5 and you get your answer. So division is also, I can also do 100 out of 20. That's also division. So all of them are different ways to write division. Division is the opposite of multiplying. So use multiplying to check your answer when you divide. Whoops, the bad S. When you divide. I think that's a great practice. You should always check your answer when you divide by multiplying. Use multiplying to check your answer when you divide. It's a great idea. I'm going to do that for, I'm not going to do that for all the problems because this will take way too long, but I'll show you how to use multiplying at the beginning to check. So once in a while, I'll check it with multiplying to show you how to check it. Okay. Everyone almost caught up. I see a couple of people writing. So hold on one second. Okay, so a couple things about dividing. It's really, 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 really important. And that has to do with 0. Dividing with 0, really important. It gets very confused a lot. So what is 0 divided by 5? Or 0 divided by 5? Or 0 divided by 5? Whatever way you want to write it. The answer is 0. Why? Because what number, I'll take this off for a second. This is how I want you to think of it. Which number do I multiply 5 by to make 0? Well, it has to be 0. 5 times 0 is 0, right? So if you have 0 divided by a number, the answer is always going to be 0. But you cannot divide by 0. You cannot do 5 divided by 0 or 5 over 0 or 5 divided by 0. It's impossible. And I'll show you why. Go back to my question. What, my question mark, times 0 is 5? What times 0 is equal to 5? There is no answer. Anything times 0 is 0. I cannot multiply anything by 0 and get 5. It's impossible. So if we divide by 0, we say that there is no solution, undefined. I think that's the one that your book uses the most, but it could be either or, no solution or undefined. There's absolutely no answer. You cannot divide by 0. So 0 can be in your numerator. 0 can be what you're dividing into something, but you can't divide by 0. Very, very, very important. And I know for sure that's going to be on your test. Be very, very careful of 0. Okay, any questions on 0? Okay, so we're going to focus on long division. You can divide smaller numbers like 10 divided by 2 with a fraction. You don't have to do long division. The long division you want to use for something that has longer, bigger numbers. Okay, so let's do one together. So let's do one example. I'm going to write it out as not a long division. And then I'm going to write it as, for most of the time, you're going to get rid of an out, and then you're going to write it as long division. So 4,908 divided by 6. So whatever you're dividing by goes on the outside. And whatever you're dividing into goes on the inside. That's how you remember it too, by. Whatever you're dividing into goes in, and whatever you're dividing by goes out. All right, so just the opposite of dividing. So this is how you have to think about it. How many 6s go into 4? A 0, right? So I'm going to skip that. How many 6s go into 49? So now you have to know your timetable pretty well. So I know 8 times 6 is 48. So I'm going to put 8. Now, really important, we divided by 49, so that 8 has to go on top of that 9. You want to keep it very, very, very organized. Disorganization can really lead to a wrong answer. Okay, so then I'm going to multiply. 8 times 6 is 48. Now we're dividing, so I need to know how many are left over. So I subtract. I know 1 was left over. Once you do that, in dividing, you bring down the next number. You could have learned it very different ways. I use an arrow. And then you do the same thing. How many 6s are in 10? Well, 2 6s is 12. So that means there's 1 6 in 12 in 10. Now I multiply. 1 times 6 is 6. I need to know how many are left over. So I'm going to subtract. 10 minus 6 is 4. And now last one, I'm going to bring down that 8. My last number. So I know this is my last multiplying. Or sorry, dividing. How many 6s are in 48? Well, 8 times 6 is 48. And I subtract and 0. This is called your remainder. A 0 remainder is beautiful. If you have a 0 remainder, it means that for this particular case, 400, no, hold on. This particular case, it means that 6 and 818 are factors of 4,908. Just means that they divide evenly into each other. So if I multiply 818 times 6, I'm going to get 818. I'm going to have 0 remainders. They're perfectly factored, perfectly multiplied. Now, of course, we're going to do some with remainders in a little bit. Okay, any question on the basic dividing by long division?
I have a question.
Yeah, go for it.
This might not be for this, but can you round down to 0, like from 1 or something?
No, it's a remainder, and I'll show you how to
Okay,
deal with a
thank
remainder. Yeah, I'll show you how to deal with remainders in a minute. Good question, though. I mean, if we're asked to round, yes, then you would, let's say the remainder was 3 and I told you to round it, then you would tell me 818, something like that. But normally, no, we need the remainders. That's going to help us. All right, so let's try another one. 4.
I'm not gonna lie, I didn't understand any of that.
You didn't understand any of that?
No, I'm
No?
really bad with long division.
Okay, long division. Okay, I'll go a little slower on this one. How's that?
Yeah, thank you.
Okay, so let's do 2,212. And don't be shy to ask, because dividing is probably one of the most difficult things to do. And that's why I asked. Tell me if you don't understand, it's fine. So you have to do each digit. So I look at the 2. Don't write that arrow. That's for, you can see, so I can tell what I'm talking about. But can I divide 4 into 2? No, 2 is smaller than 4. So I can't divide into it. Like, there's nothing times 4 it's going to give me 2, right? It's too small. Just like we did when subtracting, we had to borrow if it was too small. So we're not going to borrow, but it just means I have to move on to the next digit. If you want, you could put an X here and know that that didn't work. Now I'm going to add the next digit to it. So now I'm going to look at 22. Can I multiply 4 by something to get close to 22 or even 22? So like 4 times 3 is 12. 4 times 4 is 16. I'm getting close. Sorry, hold on a second. Okay, but 4 times 5, oh, that's 20, right? So you can do that. You can go, oh wait, okay, 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And then 4 times 6 would be 24. And I need 22. So 6 is too much. So I know it can be a 5. So 5 times 4, let me erase this. So 5 times 4 is 20. All right, I'm going to stop there. Does everything go right there? Or any questions? Ask away if you have a question. Did I explain that all right? All right, then you're going to subtract, because we got to figure out how much is left over. I wanted 22, but I could only get 20. So if I subtract, I have 2 left over. And then you always bring down the next number. Whatever's next comes down. Now, luckily, I got 21. Well, we just did all this multiplication, so we know it can't be 6, so it still has to be 5, because 5 times 4 is 20. And then if I subtract, I find that I'm left over with 1. And then whenever you're done that, you bring down the next number until you don't have any more to bring down. This is my last number, so I know after I do this, I'm done. And oh, again, lucky for me, I did all this multiplication over here. So that's cool, because I can see right here that 4 times 3 is 12. So I know it had to be 3, because 4 times 3 is 12. And when I subtract, I get a 0 remainder. Now, this one I'm going to check. And I'll show you what I mean by checking. Any questions before I check? That's all right? Some of you look fine. Some of you I just worry about. Question. Okay, so checking, here we go. I take 553, my answer, and I'm going to multiply it by what I divided by. And I should come out with 2,212, what I was dividing by, what I divided. So if not, I did it wrong. If it is right, I know 100% sure I did it right. So 4 times 3 is 12. 5 times 4 is 20 plus 1, 21. 5 times 4 is 20 plus 2, 22. And look, I came out with what I divided by. So I know my answer is good. And I put a little smiley face because I know I got right. By the way, I love smiley faces, so you might see smiley faces here and there.
That means 4 and 553 is a factor of 2,212.
You got it. You got it. Yay, perfectly said. Love it. I couldn't have said it better myself. Super proud. Hey, any questions? Anything? The next one I'm going to do is going to have remainder. And I'll show you how to deal with a remainder and how to check your answer when there is a remainder. Okay, so we are going to divide. I think I'm number 3, right? Divide. I'll write it as a fraction. 900, whoops, wrong number. 939 divided by 4. So that's a division problem, just written differently, but we're not going to divide like that. We're going to divide with long division. So 939 divided by 4. Now, I'm going to draw a line here and see if this helps too. Just look at the 9. You look at the first digit. Look at the 9. Can I divide 4 into 9? Is there something times 4 that will get me 9 or close to 9? And that would be 2, right? 4 times 2 is 8. So if I do 2, 4 times 2 is 8. I'm going to get rid of this. And I'm going to subtract. So 9 minus 8 is 1. And you always bring down the next number, 3. Now I'm looking at 13. This is where my eyes are. And this is where my eyes are here. Is there something times 4 that will get me to 13 or very close to 13? Well, I know 4 times 3 is 12. And 4 times 4. Notice I try a couple of them, right? That's 16. So this 16 is too big, but 12 is pretty good. So I'm going to do 4 times 3. It's only 1 less than 13. So that works. You have to find the number that's the closest that you can use. So 4 times 3 is 12. If I subtract them, I have 1 left over. And now I bring down my last digit, which is a 9. And when you try like multiplying things out, keep it on the side because sometimes it comes in handy. For like this one, I'm looking at 19, I'm looking at 4. Is there a number I can multiply 4 by to get 19 or really close to 19? Well, if I look back at my previous work, I know 4 times 4 is 16. Let me try the next one. 4 times 5 is 20. That's too much. So it had to be 4 times 4 is 16. Let me erase this. I subtract. 9 minus 6 is 3. That is my remainder. How do I know when I'm done? When I have no other numbers to bring down. 9 was the last number I got. So that's my remainder. So you write R remainder 3. That's how you write your remainder. And that means that 234 and 4 are not factors because we had a 3 remainder.
Can you just write R3 or do you have to have the colon there?
Say it again.
Can you just write R3 or do you have to have the
4 in there?
colon Yeah.
Okay, so you could do R3, that's fine. That's fine. It also means something else, but until we get to fractions, I'm not going to show you what remainder also means. It actually means part of a whole, and we'll talk about that when we get to fractions. But R3 is perfect. You'll see it on your my math lab. They'll have like a R. I forget what they have. They have like a big R. You put whatever the remainder is. All right. So how would you check your answer when there's a remainder? Because it's not divided evenly. So this is what you do. So we're gonna check. So we take 234 times 4. And just hold on a minute. I know it's not the whole thing, but we have to deal with the remainder last. So we're going to multiply. So 4 times 4 is 16. 4 times 3 is 12. Plus 1 is 13. 4 times 2 is 8. Plus 1 is 9. Now, of course, that's not the answer because we had a remainder. So how does a remainder come into play? Well, that's if I multiply just what I had, 234 times 4. But I know there's 3 left over. So I have to add 3 back on to check my answer because that's my free remainder. And if I do that, I get 939. And I know it was 939. So I, again, did a really good job. And that happens to be my answer. I just matched it by checking it. So when you have a remainder, you multiply the numbers you have, and then you add the remainder back in. Does that make sense? Yeah. Awesome. I know dividing is difficult. Especially gets more difficult when we do more than a digit. So we're going to hit 2 digits now. We're going to divide by 2 digits. Okay, so let's divide by 2 digits. So is this, I did again. 3, we're on 4. Okay, 4. So I'm just going to write it as long division. So we're going to do 8,920 divided by 17. And I know without a calculator, you want to grab that calculator and go, okay, I'm not doing this by hand, but you really do have to. But we're going to use I'll show you how I'm thinking when I do it, because you're going to use a little bit of logic and a little thought about it. So I don't know what it is, but I'm going to go over here and I'm going to do 17 times a couple numbers. Well, I want to do 2 because we need, by the way, I should tell you this first. I can't divide 17 into 8. I can't. So I know I'm looking at 89. So 2 would be too little. So maybe I'll try, I don't know, maybe I'll try 5. And again, I don't know. I'm just sort of trying something. So 7 times 5 is 35. Darn it. I didn't mean to get the answer the first time. Okay, 5 times 1 is 5 plus 3 is 8. That's 85. Well, let's do 17 times 6 just to make sure. 7 times 6 is 42. 6 times 1 is 6 plus 4 is 10. And don't erase them. Keep them think of like a little box. This is your work box. Keep them because you might need them for something else you're going to divide. So it has to be 5. And now I know what the answer is. It's 85. And if I subtract them, 9 minus 5 is 4, and the 8's cancel. Just like before, I'm going to bring down the next number, which is a 2. Now, nothing over here do I have in the 40s. So I'm going to have to go back and check my multiplying and see a smaller number. So I don't know, let's try 2. So what is 17 times 2? 7 times 2 is 14. 2 times 1 is 2, plus 1 is 34. Well, that's pretty good, but I need to try 3 just to see if I can do one more. I'm not sure. 7 times 3 is 21. 3 times 1 is 3, plus 2 is 5. All right, that's too much. So it had to be 2. So I do 2. Whoops, I have my eraser on again. 2. And I know right from looking here that 7 times 2 is 34. Now I'm going to subtract. So now here goes our borrowing skills. I cannot take 4 from 2. So I have to borrow. So I borrow from the 3. And again, I have my eraser on. I borrow from the 4 and make it a 3. And I add 10 to the one before. 12 minus 4 is 8. And I bring down my last digit. So whatever's left over after this is my remainder. Anybody good so far? All right, so now 80. I don't have anything as big as 80, but I do have this. This is too much. 85 is too much. So I think we need 4. So what's 17 times 4? See what we get. 7 times 4 is 28. 4 times 1 is 4 plus 2, 68. And 5 was 85, which is too much. So I'm going to have to use 4. That was 68. I need to subtract them. Again, I can't take 8 away from 0. So I'm going to borrow and make that 8 a 7 and add 10 to the 0. 10 minus 8 is 2. 7 minus 6 is 1. So remainder, I'll just do R 12.
Miss Garrett, that's a big remainder. I mean, whenever back when I was in school, that's how we used to do it. Our answers would be something like that: 524 remainder 12, or like maybe 64 remainder 6, something like that.
Exactly. Now, that's a really good question. So how do you know if your remainder is right? Well, okay, you can check it. But let's say I did this problem, right? And let's just say, I'm going to erase it, but I'll come back to it. Let's just say, for the sake of argument, that I did this problem and my remainder was 20. How do I know I'm wrong? Not this problem, but anything. I'm dividing by 17, right? That remainder has to be less than 17, or you did it wrong. Because that means you could divide more, right? So a good way to check your remainder, like I knew 12 sounded like a good number because it's less than 17. But if it was more than 17, I did it wrong. I have more to do. That makes sense? The leftover has to be less than what you're dividing by, let's put it that way. So I do suggest having like a workbox, if you want to call it a workbox, just so you keep your multiplying, because you can come back to it and always refer to it. I've known students that erase it and then they're doing the same multiplying over again. Why? You have it there, just keep it. That's like your work area. Any questions? Okay. Let's do another one. For those of you who weren't understanding it, is this helping? Don't let it be good. Don't let it go by and you don't understand it, because I definitely want to help you. Okay. Okay. All right, now we're going to do okay. It'll be 5, 6. Where are we? Always forget 5. Okay, 5. 5. We'll do another one with a double digit. And then unfortunately, we got to do a 3 digit. All right, so I'm also just going to write it as a division problem. So let's do 5,600. Sorry, 624 divided by 15. Okay, number one, you look at the 5. Can I divide 15 into 5? No. So we're going to look at 56. So I have my little work area over here, and I'm going to start thinking about this. So 15, if I do 2, I know that's 30. And actually, if you want to start and just do a whole bunch of multiplication facts and put them down, that's not a bad thing. 15 times 4 is 20, 4, 5, 6. Okay, I can stop there for right now because I see that 4 times 15 is 60 and I only need 56. So it has to be 3. So 3. I already know 3 times 15 is 45. My work over there, 45. I subtract. So 6 minus 5 is 1. 5 minus 4 is 1. Now, just like the remainder, this number here has to be smaller than the 15, or you can divide more. The book weighs about 15 pounds. Is it really? Sorry, I was distracted by that little post you just did. Okay, sorry. Okay, 11. So now, what do you do next? You bring down the next number. Oh boy, 15 into 112. We got a lot more dividing to do. So let's see. I'll just keep on going. 15 times 5. 5 times 5 is 25. 5 times 1 is 5 plus 2 is 7. And I know the temptation is to grab a calculator, but don't, you will win out at the end. 6 times 5 is 30. 6 times 1 is 6 plus 3, that's 90. Oh, we're getting there. 15 times 7. 7 times 5 is 35. 7, 8, 9, 10, 105. Let's do 15 times 8. See what I'm doing? I'm building up a whole bunch of numbers that I can use as help. 8 times 5 is 40. 8 is 1 is 8. 9, 10, 11, 12, 120. Now that's too much. So I know it has to be 7 because 7 times 15 is 105. I should track them, but I guess again, I'm borrowing. So I make 1 is 0 and I add 10 to the 2. 12 minus 7, that's 12 minus 5. I do this all the time. The answer is 7. And the 7's in my head and I say 7. I'm at 5, but I know the answer is 7. I bring down the 4. Now I have this work done, right? Look over here. 15 times 5 is 75. Well, that's too much. I need 74. So that means it had to be 15 times 4. That's 60. 14. Remainder 14. Well, that is less than 15, right? So the remainder looks good. And of course, you can always check it, which I'd highly recommend checking every answer. Now, if you want to check your answers with a calculator, that's fine. I have no problem with that. Can't do it on test, but you can do it at home. Just do it by hand while you're doing it and then check it with a calculator. And actually, that's for everything. If you do it by hand and want to see if you're right, grab a calculator and check it. That's not a bad thing. That's a tool. Doing it with a calculator and not doing it yourself, that's what you want to avoid. All right, any questions? Because we're going to go to a 3-digit, which gets, of course, harder.
There's a lot of division, Miss Garrett.
It's a lot of division. Well, I'm looking at the time. It's 11:19. Everybody see the time? I was going to go to the next problem, but I don't think we have time. Okay, so we have 3-digit division to do. And we got to talk about averages. So we will pick up on Tuesday. We will do 3-digit division. I'm going to make myself a note. Next. 3. This time goes by so fast. 3-digit division. And that's where we're going to pick up next. And then we'll go on to the last 2 sections. And then that's it.